Hello everyone, I am Mahalakshmi Ramesh from second year Computer Science and Engineering at Shriram Engineering College. Today I will be explaining the Java program for topological sorting, decrease and conquer using Kahn's algorithm.
So in this video, I'll explain topological sorting. So topological sorting is just a way of arranging things in a correct order so that when some tasks must be done before the others. So topological sorting is only used in a directed graph where the direction of the edge shows dependency. So if there is an arrow from U to V, it means that U must be completed before V. One important condition, that is the graph must not contain a cycle. So if a task depends on itself indirectly, then topological sorting is not possible. In simple terms, topological sorting ensures that every task is done only after its required tasks are completed. So this concept is widely used in task scheduling, course planning and dependency management. So now I'll be explaining the code for topological sorting, and so this is the code which performs topological sorting in a directed acyclic graph. So now I'll be explaining what's really going on here. So first we are going to import the Java utility package so that further on we can use the utility concepts like array list, queue, linked list and scanner. So we have done that right here. We have imported a utility package for Java. Next, this is our main class which will be performing the algorithm for topological sorting. So DC here stands for decrease and conquer. Next, in the class we will be declaring an integer v which stands for the vertices, and here we are going to create an adjacency list that represents the directed graph. So this is an integer adjacency list. Next, this is a constructor which takes the parameter v, that is vertices. So this constructor initializes the graph so that an empty adjacency list is created for each vertex. Next, so after the constructor we have added a method called add edge. So this method adds a directed edge from vertex u to vertex v. Now from here we are going to start our main concept for topological sorting. We have created an array called in degree. So here in degree means the number of incoming edges, and we are going to calculate the in degree by checking for every edge from I to x, the in degree of x is incremented. Next is queue creation. We are going to create an integer queue, and which is going to process the number of vertices with in degree 0, which means that vertices which does not have any edges directed towards it. So if the vertex that has no in degree, which means that the vertex which has no dependencies are added to the queue first, and here this is the resulted array, sorry, the resulted list, and this list will store the final topological order. Now this is the main processing loop. This while loop is the main processing loop. So we have removed a vertex from the queue and add it to the result one by one. Now for each adjacent vertex we reduce its in degree. So if it becomes 0, then the vertex is added to the queue, and this is where the decrease and conquer algorithm happens. Now we are going to check the cycle over here. So which says that if the graph contains a cycle, which means if all the vertices are processed, then the graph contains a cycle. and we get the output as the graph contains a cycle and the topological sort is not possible. And else, if the all the vertices are processed correctly, then we get an output of the resultant topological sort. And we get our result over here. The topological order of the graph is printed, and from here our main method is started. We are going to create an scanner object for reading the value for the number of vertices as V and the number of edges as E. And now we create an object for our class. The edges are entered in the form of U and the vertices are entered in the form of V. This is taken as a key value pair and it represents the directed edge. So after getting the inputs, after reading the inputs for number of vertices and number of edges and also taking the key value pairs of the vertices and edges consequently, we call the topological sorting method, and after that we get the output as either the graph contains a cycle or we get the topological order of the graph. So, and after that we close the scanner object, and now let's take an example output. Now for the number of vertices we enter 6 and the number of edges again 6. Now for the enter edges and vertices U and B, we enter 5, 2, 5, 0, 4, 0, 4, 1, 2, 3 and 3, 1. Yeah. So for this directed acyclic graph, we get the topological order as follows. So first the vertex 4 is visited, then 5, then 2, 0, 3 and 1. Now let's take an example for a cyclic graph. Let's see what kind of output we get for a cyclic graph. So for the number of vertices, we enter 3, edges 4, 0, 1, 1, 2, 2, 0 and 1, 1. Yeah. So this graph is directed, but it is a cyclic graph. Therefore, we get an output as a graph contains a cycle, and therefore topological sort is not possible. So yeah, this is the entire Java code for performing topological sort using decrease and conquer Kahn's algorithm. I hope this video was useful, and we'll see you guys in the next video. Thank you.